Hello, talking about more CRI math. This one is going to have multiple drugs in a bag of fluids, and we're going to run it a little bit like the syringe pump one that we did before this, where this is for an individual patient, and we'll talk later about how to make a syringe or a bag of fluids that would be at a different concentration, and that concentration would be safe to run on any patient, and we'll figure that one out. But for now, if we're talking CRI math and we want multiple drugs, we're thinking about, of course, what doses are we going to pick. So I've already assumed, let's say I've got this dog. She needs a splenectomy. She's a lab, 6-year-old. So I say 6-year-old because she would be safe with any of these drugs, especially because they're low dose. And she's 77 pounds. So I need a larger volume than a syringe pump could probably handle. And I'm also going to be thinking about how long is my procedure, just like the last one. Well, in this case, it's slightly different because I know my procedure is going to be pretty quick. Even the prep for the anesthesia, getting into the procedure of the splenectomy, ending anesthesia and recovery time. I mean, we're only talking about an hour, right? Because this is an emergency procedure. It all goes very quickly, but this kid's got to stay in the ICU. So I don't want them to stop pain meds just because the surgery's done. That's not how pain works. So I'm instead going to say, okay, it's 5 o'clock, 6 o'clock at night, and this pet's going to have to stay in ICU. They're not going to be released anytime soon. So 8 hours. I'm going to assume at least 8 hours, and then after that, the nurses in the ICU can make a decision on where it's going to go. And a 250 ml bag of saline is nice and small. It's going to help me keep down the volume of drugs I have to add. And I say that just as a way of saving money and saving drugs. One thing that I always hated in the ICU was when I had to throw away a bag of HLK or fentanyl because somebody filled it at too high of a concentration. Pet went home. We didn't need it. It's a relatively full bag. You know how it goes. So I want to think about how can I be economic as well. And the 250 also helps because this dog has to also be on maintenance fluids like LRS, like Phyllite, like Norm R, like whatever safe crystalloid we have that we can run on this patient at higher or lower rates depending on dehydration, blood pressure needs, all those things. So with all of that said, now we have to go over to our calculator, and we'll take our 77-pound lady divided by 2.2, which is the conversion factor for pounds to kigs or kigs to pounds, and we're going to get 35 kigs. And then we can go right to our first drug we picked, hydro. So 35 times 0.05 mg per kg per hour. And we take that times 0.05 on our calculator. That equals 1.75 mg per hour. And remember, kigs cancels in that particular equation. So we're left with mgs per hour. But again, just having a dose per hour is not helpful. We've already said we need it times 8 hours. So back to the calculator, 1.75 times 8 hours gives you 14 mgs. Because again, hours cancels out in that equation. 14 mgs still isn't good enough because I can't add mgs to a bag of fluids. It has to be mils. So concentration of hydro is 2 mg per mil. Take 14 divided by 2, and you get 7 mils hydro. So we hang on to that number because we need it. The next guy is 35 times lidocaine, 1 mil per kg per hour. Don't even need a calculator. That's 35 mil. Oh, excuse me. This is mig per kg per hour. That will equal 35 mig per hour. Again, kgs cancels in that equation. But per hour is not helpful. We need it for the full 8 hours. Please and thank you. So we would take then 35 times 8. And that's going to get us 280. 280 mig. Because hours cancels. 280 mig isn't good enough. We still need mils. So lidocaine is 20 mil per kg, or excuse me, mig per mil. 20 mig per mil lidocaine. So 280 divided by 20, the concentration, and that gives you 14 mil lidocaine. Hang on to that number. Next one, 35 kgs times our ketamine rate we're going to run at, 0.5 mig per kg per hour. And we go to our calculator, 35 times 0.5 gets us 17.5 mig per hour. But it's per hour. We know this. Take it times the 8 hours that we need. And that gets you 140 mig. So now we have 140 mig. Not good enough. I need mils. So 140 divided by ketamine's concentration of 100. And that will get you 1.4. Well, it would if my calculator worked, but it's 1.4 mil ketamine. Great. So I've got 7 mils, 14 mils, and 1.4 mil that I need to add to a 250 mil saline bag. But there's a thing called the QS, the quantity sufficient. What that means is if we start with 250, that's what we were calculating everything for. That means we have to end with 250. We can't get too much or too big of a dose or too high of a dose in there. So if I add 7 plus 14 plus 1.4, I'm going to get 22.4. You forgive my cat over there. She was trying to kill something. I don't even know what she's doing. Anyway, all that excitement for math. So when we add these up, what does that tell me? That tells me I need 22.4 mils of room in this saline bag. Otherwise, I will be over 250. And if we start with 250, we end with 250. So all that means is that I'm going to take out 22.4 mils from that 250. So I just take a syringe and a needle and I pull out 22 mils, and then I take a small 1 cc or tuberculin syringe, I remove 0.4, and that will get rid of the 22.4 mil of saline and make room for these guys. Oh, wow. The cat has just decided to kill. I think there's a mouse in here. This is a terrible video. I'm sorry, but maybe it's entertaining. I don't know. But we've just made room in our bag of saline by taking out that 22.4. So now I can add in 7 and 14 and 1.4, which makes up that 22.4, and I get back to a total of 250. Now you're probably saying, what rate should I run this at? I don't see where that comes in. Sure you do. You know if this has to be run over 8 hours of time, and my total volume is 250, you take your 250 mils divided by 8 hours. And that's going to give you a rate per hour to run it at, which is 31. And the 0.25, I don't know if most pumps will do that. So I would say I'm just going to run it at 31 mil per hour. And if I run it at 31 mil per hour, that entire bag should run out in 8 hours. So let's try to do a visual and see if that helps. So we've got 1, 2, 3, 4, 5, 6, 7, 8 chunks in our bag of saline, that 250 mils, split evenly into 8 hours. And so this chunk right here, this 31 mils in 1 hour that I'm going to be given, I know it has the correct amount of each drug in it because I've calculated it to be so. I've divided this entire 250 by 8 chunks, 1, 2, 3, 4, 5, 6, 7, 8, to know that this one chunk of 31.25 mils run in 1 hour's time has the correct dose in it. Same thing here. This chunk of the bag, which is 31.25 mils, is going to have the correct dose in it for each hour. And if we go back up here and we see each hour is going to have 1.75 mig per hour of our hydro and 35 mig per hour of our lidocaine and 17.5 mig per hour of our ketamine, because that's how we calculated it out to run. So then you're going to put on your additive label, and on most additive labels I will write out how many milligrams I've added total of each drug. So for hydro, again, up here it was 14 mig. For lidocaine, it was 280 mig. For ketamine, it was 140 mig. And I write that out. And then I'm going to say something like run at 31 mil per hour so that we can achieve certain concentrations. And if I have enough space, I will write to achieve then the 0.05 mg per kg per hour of hydro, the 1 mg per kg per hour of lidocaine, the 0.5 mg per kg per hour of ketamine. I tried to be as obnoxious with words as possible on my additive label so that anybody walking by it can go, okay, so I see we have this many mgs to add if I, the nurse coming on, has to remake it. And I can see at what dosing is it being run at. Because maybe I, the nurse coming on the next shift, say, gosh, I wish we had more pain-killing abilities in this bag. Maybe I'm from hydro. I don't want 0.05 anymore. Maybe I want 0.1 mg per kg per hour because I don't feel he is analgesed properly. So that's why I would just be kind of verbally vomiting on my additive label if I can. You have to refer to your policies and procedures for that, of course. But I like to be obnoxious when I can. So that was how you would make a bag of fluids with CRI analgesics.